हेलो स्टूडेंट्स, मैं हूँ भट्ट मैम। आज हम पावर इलेक्ट्रॉनिक्स का फर्स्ट यूनिट देख रहे हैं और इसमें हमारा आज का टॉपिक है MCT, दैट इज़ मॉस कंट्रोल थायरिस्टर। What is MCT? MCT is a new device in the field of semiconductor control devices. It is basically a thyristor with two MOSFET built into the gate structure. You can see basic structure of MCT here. Okay. One MOSFET is used for turning on the MCT and the other for turning off the device. An MCT is a high frequency, high power, low consumption drop switching device. An MCT combines in the features of both conventional 4-layer thyristor having regenerative action and MOS gate structure. However, in MCT, anode is the reference with respect to which all gate signals are applied. In a conventional SCR, cathode is the reference terminal for gate signal. Okay, now let's see the basic structure. As you can see, this is the basic structure on the left side of the video. This is the basic structure of MCT, and you can see circuit symbol of MCT on the right side. Okay. Now let's see what is basic structure of MCT is. The equivalent circuit of MCT is shown here. It consists of one on FET, one off FET and two transistors. One on FET, a P-channel MOSFET, and the other is off FET, an N-channel MOSFET, represent MOS gate structure of MCT. The NP-NP structure of MCT. Okay. The NP-NP structure of MCT is represented by two transistors NPN and PNP, which is shown here in the figure. An arrow towards the gate terminal indicates N-channel MOSFET, and the arrow away from the gate terminal indicates the P-channel of the MOSFET. The two transistors in equivalent circuit indicates that there is a regenerative feedback in MCT, just as it is in any ordinary thyristor. An MCT is turned on by a negative voltage pulse at the gate with respect to anode and is turned off by a positive voltage pulse. Now let's see turning on and turning off process of MCT. First we will see turning on process. MCT is turned on by applying a negative voltage pulse at the gate with respect to anode. In other words, for turning on MCT, gate is made negative with respect to anode by the voltage pulse between gate and anode. MCT must be initially forward biased and then only a negative voltage be applied. With the application of this negative voltage pulse on FET, P channel gets turned on, whereas off FET is already off. With on FET on, current begins to flow from anode A through on FET, and then as the base current and emitter current of NPN transistor, and then to cathode K. This turns on NPN transistor. As a result, a collector current begins to flow in NPN transistor. As off FET is off, this collector current of NPN transistor acts as the base current of PNP transistor. Subsequently, PNP transistor is turned on. Once both the transistors are on, regenerative action of the connection scheme takes place and the thyristor or MCT is turned on. Note that on FET and PNP transistor are in parallel when MCT is conduction state. During the time MCT is on, base current of NPN transistor flows mainly through PNP transistor because of its better conducting property. Now let's see what is turning off process. For turning off the MCT, off FET, that is N-channel MOSFET, is energized by the positive voltage pulse at the gate. With application of positive voltage pulse, off FET is turned on and on FET is turned off. After off FET is turned on, emitter gas terminals of PNP transistor are short-circuited by off FET. So now anode current begins to flow through off FET and therefore base current of PNP transistor begins to decrease. Further, the collector current of PNP transistor that forms the base current of NPN transistor also begins to decrease. As a consequence, base current of both PNP and NPN transistor, now devoid of stored charge in their N and P bases respectively, begins to decay. This regenerative action eventually turns off the MCT. Now let's see what are the VI characteristics of MCT. Here in this diagram you can see what are VI characteristics of MCT. An MCT has a static VI characteristics as it is shown in figure. This characteristic is similar to the VI characteristics of GTO. MCT has a low reverse voltage blocking capacity. It can be turned on and turned off by gate signal. An MCT gets turned on and turned off through regenerative action like an SCR. In MCT, forward on-state voltage drop increases slightly with anode current as in a thyristor. It is a voltage control device like PMOSFET and IGBT. It is necessary to keep the gate signal applied during both turn on and turn off state. In case gate signal goes to zero, there may be a possibility of unwanted turning on and turning off of MCT due to high dV by dt values appearing across MCT. MCT has following merits, or we can say advantages of MCT. It has low forward conduction, fast turn on and turn off time, low switching losses and high gate input impedance. And the main disadvantages of MCT is that it has low reverse voltage blocking capacity.